Single replacement metal activity series. So, as a quick reminder, what happens during a single replacement reaction? So, the lone element, in this case potassium, kicks out an element from a compound, in this case hydrogen. So, potassium and hydrogen here are kind of swapping places. So, now we have potassium hydroxide and hydrogen is by itself. Now, hydrogen, since it's by itself, is going to be diatomic. We have H2 here. Now, this only works because the lone element, potassium, is more reactive than the element it replaces, which is hydrogen. If this was not the case, then we would see no reaction would occur. So here we have some data that was collected by taking different metals and reacting them with the sulfate salt of the different metals to see which one can replace the one in the compound. So for example, in the first row, we see that magnesium metal is able to replace zinc in zinc sulfate. We see a reaction. But zinc metal is not able to replace magnesium when it's in magnesium sulfate. So what is the most reactive metal? That's going to be magnesium because it can replace zinc, it can replace iron, and it replaces copper. So it has the most reactions. So copper would be my least reactive. It cannot replace any of the metals in the compounds. So to put them in order by reactivity, we'd start with magnesium, we'd have zinc, iron, and at the bottom we'd have copper. And if we compare this list, this is called an activity series, and it helps us to determine if one metal will replace another metal in a compound. So if we compare the list that we came up with previously with this list, we see that our results agree. So magnesium metal can be used to remove tarnish from silver items. Silver tarnish, silver sulfide, is the corrosion that occurs when silver metal reacts with substances in the environment, especially those containing sulfur. So why would magnesium help to remove tarnish from silver? It's because magnesium is more reactive than silver. So instead of forming silver sulfide, which is tarnish, we form magnesium sulfide, and our silver stays clean. So use the activity series for metals to explain why copper metal is used in plumbing, where water might contain compounds of many different metals. So copper is really low on that activity series, so it's not going to react with most compounds dissolved in the water. So the copper pipes will stay intact. It used to be that pipes for plumbing were made out of lead. And the problem with that is that you end up with lead ions in the water. And this is because single replacement reactions occur between the compounds in the water and the lead. Now, modern homes, the plumbing is made of PVC because that is even less reactive than any of the metals.